So now we are taking a look at sort of behind the supply curve. Last unit was about demand more and functions of the demand curve and what happens when you move along it and why it's downward sloping. Now we're taking a look at supply and what's going on in individual firms. So we're also taking a step a little bit closer. So we were looking at markets before. Now we're looking at firms. Um, and this is a short unit just on firm costs. And to have a greater understanding of it, we need to take a look at production functions. This is the relationship between a firm's output and its input. So if you imagine its output being the y-axis, you see it on the graph here, and the input being on the x-axis, you see how it's shaped. And it has a bell curve, as a lot of things in microeconomics do. You notice that it is increasing, output is increasing at a decreasing rate as you add more input. And today's going to be a lot about why that is the case. Now, you may be wondering, are you ever going to have to draw a production function? No, it's never been on the AP test. Don't worry about it. But be able to interpret a graph like this. If this showed up on a multiple choice question, you should be able to describe what it is demonstrating. Now, to go a little closer, thinking about inputs and outputs, there are two main types of inputs: variable inputs and fixed inputs. Variable, these are ones that can be increased in at any point. These can be increased, I should say decreased as well. These can be changed. Things like labor, things like certain raw materials, these can be purchased in a relatively short amount of time. They don't require a whole lot of planning. Fixed inputs, however, cannot be changed in the near term. Uh, these are in AP economics, in most cases, this has to do with sort of your factory size or your plant size. This is something that would take an undefined time in the future to be able to change. You can't go out tomorrow and buy a new factory. You have to search for the factory, draw up contracts to purchase it or rent it, and then actually move your stuff into it. That's going to take time, and figuring out exactly how much time is kind of difficult. So that's why it's a fixed input. It's fixed in the short run. So this now gets us to short versus long. Short run is at least one input is fixed. So at least one input is fixed in the short run. Now we don't have a typical, we don't have a an actual timeline here. It's not like you're going to get a question that says in the next 6 months. That's just not going to be the thing. Any question you get will specify short or long run, but short run just means that at least one thing is fixed. In most cases, it's going to be the plant size or certain types of capital. Long run, everything can vary. We are going to be taking a look at the long run, in which you will have different factory sizes, which will show you different levels of short run output that you can do with each of those levels of fixed input. You don't have to know too much about that yet. Just know these basic definitions: that short run has one input that's fixed, long run, everything can change, even though we will still refer to things as fixed versus variable inputs, even in the long run. If we look at our total product, you should see that it's represented by your production function. Your production function shows your total production. This is another example of a total product graph or a production function graph. You see that the input here that can be changed is labor. That's going to be the most common one that you see. And the outputs on the Y once again. And you notice that your output is increasing as you increase your labor. It's increasing at a decreasing rate. Now, once again, that's going to be important. Now, normally when you do this, you assume everything else is fixed. You isolate one input at a time, not trying to do all of them, because that would just be too difficult to figure out each one's impact on output. Now, whenever we're talking about these bell curve graphs, we have to think about marginal product. So the difference in total product. So for this, it's the additional output that you create as a result of hiring one more unit of the input. Now, notice my phrasing there: hiring of one more unit of the output. That means that even if we're talking about capital or machinery or something like that, we hire that input. It might be phrased otherwise, but in a lot of cases, you will see it as hired, even though it's an inanimate object. So don't get confused by that. Now, um, if we're looking for an equation for this, it's the change in total output over the change in whatever your input is. Normally, it's going to be labor. So your MP sub L is your change in total output divided by your change in labor. If it's your marginal product of capital, MP sub C, that's your change in total output divided by your change in capital. Sometimes you'll see capital as K in this, so MP sub K. That's to not confuse it with certain other things that are also labeled MPC. Now, in most cases, you're going to be able to ignore the idea of change in labor or change in capital, whatever your change in input is, because in most cases, it's going to be a change of one, because you're going to be looking at it as one. There will be isolated cases where it might be more than that, but in 9 cases out of 10, it will be change in total output, and then your change in labor or capital or whatever it is will be one. So really the answer is just whatever your change in total output is. Now, when we look at that marginal product, and we'll look at this on graphs coming up, you'll see that you should have diminishing returns to an input. As more of a variable input is added to the fixed input, your marginal product will decline. And this has to do with having to share fixed inputs. So if you think about if you've ever worked in a business, when you are on your own, you can be very productive. But as soon as you start adding more people, well, then you might start talking to them. You might start having to use the same cash register or machine or whatever you're using. Um, and that person now is starting to get in your way. You might be more productive in total of your output with more and more people there, but your marginal productivity, you specifically as a worker, is going to decrease. That's diminishing returns to an input. And then if anybody has ever worked in a job where they just have too many people working at the same time and you actually get less done, that's when you have uh, your total product decreasing. So if you look at this, this is a production function. You see cups of lemonade being your output, units of labor being your input, and you see it's increasing, once again, at a decreasing rate. That's showing that your marginal product is the greatest as you add your first unit of labor. Then your second, it goes down a little bit. Third, it goes down a little bit. Fourth, it goes down a little bit, and down and down and down until it eventually starts turning negative after your sixth unit of labor. That's diminishing marginal returns. It's very similar to diminishing marginal utility. It's the same basic concept graph wise, but for little different reasons. Now, what does this look like on the marginal product of labor? If you're looking at it as a marginal product, so marginal product on the Y, quantity on the X, you see that at first, yes, in most cases, it will actually raise a little bit at first. And this has to do with specialization. So if you're trying to do everything at once, you might not be super productive because there's just too much for you to do. However, once you add somebody else, you can specialize. So sometimes you can have increasing returns, but only in the lower levels of the input. As soon as you get beyond that, diminishing marginal return sets in, and that lets you know that your marginal product should be decreasing as you increase the output.